Okay. Any questions on that one? Okay. Looking at number three, Austin and Temple are 50 miles apart. Okay. Are they? 50. Bonnie drove from Austin to her daughter's house in Temple, averaging 60 miles an hour. Leaving the car with her daughter, Bonnie rode a bus back to Austin along the same route and averaged 40 miles per hour on the return trip. What's the average speed for the round trip? So, what is average speed? It's, well, we know velocity is equal to distance traveled over time. So, what is the average speed? I hit the camera. Is it fine? Okay. It's equal to distance total over time total. But we obviously know what distance, the total distance is, because he's going down and back. So it's 2 times 50. That's the total distance. But now we want to find the total time. And how do we do that? Well, let's just move these variables around. We know time is equal to distance over velocity. So the time there, so I'm going to call that time 1. What is that equal to? 50 miles over 60 miles per hour, which is equal to 5/6 of an hour. Okay, and now on the trip back, he only averages 40. So the time back, 50 miles or 40 miles per hour. So what is this? We get this as 5/4 hour. And now for time total, we just add them. So this is 50 minutes. And this is 75 minutes, which leaves us with a whole total of 125 minutes, which is equal to, I think, 25 twelfths of an hour. So if we do this, 25 twelfths hour miles, what do we get? We've canceled it 2. We get 4 miles over 1/12 hours, which equals 48 miles per hour. So the final average is 48 miles per hour. This is a common question you'll see in AMC's math counts. You'll see it everywhere. You just need to know that the speed is equal to the distance over the time, and the average speed is equal to the total distance over the total time. So if you know we want to find the average, we want to just find the total distance, which is easy. And then we just have to find the trip going there and the time going back. Add them, and then you just get your final average velocity, 48 miles per hour. Any questions on that? Okay, if there's no questions, let's move on to the next one. Oh, how do I get 25 over 12? Oh, that's just five. Okay, 5/6 plus 5/4. If you cross multiply, you get 20 over 30 plus 30 over, this should be 24 over 24, which equals 50 over 24, which equals 25 over 12. So that's the total time. I just jumped across multiplying in my head. But yeah, we're looking at the total time. So the time there plus the time back, and we add those together, and the total time is this many hours. On to question 4. So, two angles of an isosceles triangle measure 70 and x. What is the sum of the three possible values of x? Well, let's think about it. What's the most obvious case? Well, there's two obvious cases, I guess you could say. The first one is x equals 70. What do we get? We're going to 70, 70, 40. This is our isosceles triangle. And now let's think about it. So really what we're considering is what angle is at the top. So this time we chose 40 to be at the top. So now let's choose x as the vertex. x 70, 70. But the sum of all the angles in a triangle must be, well, 180. So what is x? X equals 40 here. But there's one more case. Instead of having one x, we can have two x's. And once again, the sum of the angles in the triangle equals 180. So you get 70 plus 2x equals 180. 2x equals 110. X equals 55. X equals 55. We sum these together, you get 70 plus 40 plus 55 equals 165 degrees. This one is not too difficult. You just had to think about the triangles. What you just want to think is we get to cycle all these. So you have a 70 and an x always. And you want to just figure out what the last one is. So if you put 70 and x on the bottom together, you have to figure out this. So that's the case. You can always have x at the top, 70 at the bottom, and have this last be 70. Find out what x is. And you just can rotate it around. So this one is you just had to think about what the three possibilities are, and if you could find those, the problem should come pretty easily. Okay, and the last question. This one, some of you guys counted everything. That seemed really painful, but I'll show you the trick. You do not need to count every single one. So let's think about it. Okay, so what do we know? We know we have a perfect cube. So no matter, so the base, no matter what, is a 1 by 1, right? Because we're cutting parallel. Every single base is a 1 by 1. So the bottom of A, the bottom of B, the bottom of C, and the bottom of D all have a surface area of 1. So let's check the surface area of the bottom. What is that? 1 plus 1 plus 1 plus 1. Now let's look at the top. The top is the exact same thing as the bottom. Every single one is a 1 by 1. So what is this? Surface area of the top equals 1 plus 1 plus 1 plus 1. And now the sides. We don't want to calculate the missing lengths and all that. That's very painful. And we just generally don't want to work with that. But if we let's think about it. Let me draw this. This is purely a side view. So we're only looking at the sides. Right? Let's rearrange it. Let's forget about every single surface area except the side. We're only looking at the side. So let's call this, and we'll call this areas A, B, C, D. The surface areas. The proportions might not be right, but just I don't know. You can see what I mean. So now we're rearranging. A. So this is the surface area of A, right? So these are the surface areas. We know A plus B plus C plus D equals 1. Because we're still looking at an entire um, one moment. Okay. So what we're seeing is A plus C, B plus C plus D equals 1, right? And now look at the side view. A, and we know right next to this is B. This is C. This is D. So what is the area of this? What is the area of this side? Well, let's add up the parts. A plus B plus C plus D. Wait, but we know what that sum is. So the area of one side is just 1. We knew it was 1 in the first place. And what are we doing? We're just rearranging it. You're just moving the B over. So we move this over, and this over. We're not changing the area of the side. We're just rearranging things. It's like saying if I had 4 pennies and they're like here, 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 here. If I move the pennies from, so say the pennies were stacked. So I had 4 pennies stacked on top of each other. If I moved like 2 pennies here, nothing here, a penny here, and a penny here, it's still 4 cents. It's just a different orientation. This is the exact same idea. The surface area of the side is exactly the same, except we're just moving around the blocks. So that means the surface area of the other side must also be 1. And now we have everything. We have the top, the sides, and now we have just one more thing to look at. The surface area of the other side. Again, so what do we have? Side 1, we know that's 1, and we know side comma 2 is also 1. And the last side we need to consider is this one. And if we look at a pure side view, what do we see from one side? We see big rectangle. So we get the small one of B right here, and the little one of C. And we know the height of A. This is 1/2, because this big one is A, this is B, this is C. This has a height of 1/2. This has a 1. Wait, but now we're at a side view, and it looks really different now. Now it looks like just a rectangle with length 1 and height 1/2. So how do we work with that? Well, if we look at it like this, we just see 1/2 times 1 is 1/2. That's what we need to think. If we just consider it, if it's stacked out, I'm a terrible artist, by the way. So if this is our top, and then we come out of it, that's like this. You would come out of it again. Like, once again, I can't draw. Let's think about it. We have this plus this plus this. Let's think of an easy way to visualize the area. Let's just pretend we push them. We push this so it lines all the way up, and push this over so it lines all the way up. What do we get? We just get these touch, these touch. So now we just have a height of 1/2 and just a length of 1. So the area of this side is 1/2. Let's look at the other side. You have the big block A right here. Just draw this. But then you also have the little block of D right here. Once again, it's the same idea. It's 1/2 height again because it's A, and we were told A has a height of 1/2. And this is a length of 1. Now we can obviously draw this out again. Oh, how do I draw this? Something like this. Draw it out. We like this has area D, this has area A. We can add them. We can break it all apart and add them. But it's so much. But if we just think about this, we push this all the way forward, right? Once again, we got to just complete like solid wall with a height of 1/2 and a length of 1. So this side also has surface area of 1/2. So what do we have in total? We have the surface area of the bottom, which is 4, the surface area of the top, which is 4, the sides, the first 2 sides we calculated, just 2, and now we have 1/2 plus 1/2. Okay, so what do we have as the total area? It's 11. Did you guys get that one? This was the hardest one on the set. Uh, Calculating top and bottom wasn't supposed to be too difficult. The hardest thing was to think about on the sides. You're just rearranging the blocks. You're not changing anything. This total height, because like it's blank height times 1, blank height times B, blank height times A, blank height times D. So just A plus B plus C plus D times 1. But we know what the sum is. It's 1. So we know this side is 1. And because it's the rectangles, the other side mirrors. And on this, you just had to think, wait, it's the same idea as the last part. Now it's just arranged differently. Instead of being on the sides, it's up and down now. You just gotta think, oh wait, there's a height of 1/2. And if we push these all forward, it's just 1 times 1/2. And that's it. Are there any questions on 5? If there aren't any questions, let's work on classwork number 1, which I have posted. So week 3 classwork 1 is what we want to work on right now. And if you have any questions on anything, you can just message me. But yeah, I'll give you 20 minutes to work on classwork 1. So at 8:45, we'll come back together, go over the problems. I'll give you a break, and then we'll do the last set, and that'll be it for today. And once again, if you finish, you can message me through private messages and I'll answer. Just a couple more minutes, like 2, 3 more minutes. If you're not done, no worries, but just send me what you have. Like, okay, let's go over these questions. While I go over these, if you haven't sent me your answers, please send them to me so I can gauge where you are. But yeah, let's start with number one. I gotta write my pen. Okay, question one. In the country of East Westmore, statisticians estimate there's a baby born every 8 hours and a death every day. To the nearest hundred. Some of you missed to the nearest hundred part. How many people are added to the population of East Westmore each year? So let's think about it. So every day, how many hours are there in a day? There's 24. What's 24 divided by 3? 8? I meant that's 3. So every day, there are 3 people born and one die. So what is that in total? So you gain 3 people, but you lose one every day. So in reality, only 2 people are added to the population each day. Now, how many days are there in a year? There's 365. And if we get 2 people each day, this equals 730. But because we have to round, in reality, it's only 700. So 700 people. Okay. On to number two. This took so little room, I'm not going to waste this piece yet. How many four-digit numbers greater than 1,000 use the 4 digits of 2012? So, must be greater than 1,000. So what do we know? We can't start with 1. So let's think about it. You start with 1. You're gonna have okay. Now, what else? We can start with a 2. It's 2, 2, 0, 1, 2. Again. So if we're going with the counting method, how many do we have? 1, 2, 3 start with 1. And the other possibility is we start with 2. So there's 6. 3 plus 6 equals 9. But there's actually a faster way to do this. If anyone here understands combinatorics, there's 2 cases. There's case 1, where 1 is first. Then we need to find how many unique ways can we rearrange 0, 2, and 2. What is that? 3 factorial over 2 factorial. Because there's a repeat. It's 3. And case 2, there's a 2 is first. So we need how many ways can you arrange 2, 1, 0? Well, 3 factorial over nothing. Because all the numbers are unique. 6. If you understand combinatorics, do this, but this is perfectly fine. If you go this, you're fine. You'll get it right. 3 start with the 1, 6 start with the 2. Total is 9. Okay, that's 1 and 2. Okay. What is the smallest number greater than 2 that leaves a remainder of 2 and divided by 3, 4, 5, 6? So, let's think about it. Let's go back 2 steps. So let's find a number 2 smaller. Let's think from that. 2 smaller than what we want, because that's easy to work with. What is a number that when divided by 3, comma 4, comma 5, comma 6 equals 0? This sounds a lot like what GCD means. I mean, not GCD, LCM. What is this? So to find the smallest number that all these divide, we're actually just finding the lowest common multiple of these numbers. And what is that? That's 60. But remember, we took 2 steps back at the beginning. So we said, if they were finding number 2 smaller, so now we have to add the 2 back. So you get. So we just need to think about, wait, everything divided by 3, 4, 5, 6 divided by this number has a remainder of 2. So let's look at the number 2 smaller. 3, 4, 5, and 6 all divide this number, are divisible. So what does this mean? It means that we have 60. But we said we took 2 away, so we have to add 2, 62. And if you're doing combinatorics, this is just a modular arithmetic question. And if you really want to think about it, 6 is divisible by 3. So if it leaves a remainder of 2 with 6, it must leave a remainder of 2 with 3. So you don't even have to count 3, but it doesn't matter for this question. Part 4, question 4. Marla has a large white cube that has an edge of 10 feet. She has enough paint to cover 300 feet. So you want to find the size of the squares that aren't covered. Okay, just think about it. What is the total surface area? Total surface area equals 6 times the area of one face. What is the area of one face? 10 times 10. We have a total surface area of 600. But we also know that the green paint covers 300 square feet. So because everything is even, instead of looking at all the sides, what if we just looked at one side? Let's divide everything by 6. The surface area of one square is 100. And because the paint is distributed evenly, and we have 300 green paint in total, each side gets 50 green paint. So green equals 50. But what do we know? The green plus the white must equal 100. Because painted plus unpainted must equal the entire square. And we know for each square, the green paint covers 50. We got 100 minus 50 equals the amount of white. And each one is left with a 50 square foot square. So 4 is 50. So what do we have to think about for this one? The first step is, wait, every single one look the exact same, which means that the paint is perfectly evenly distributed across all 6 faces. So instead of thinking about the whole cube, let's think about just one face of the cube. So one face of the cube gets 50. So every single face gets 50 square feet of green paint, but each face is 100 square feet. So 100 minus 50 is 50. So we're left with 50 feet that aren't painted, and that is the size of your square. You don't have to calculate lengths or anything. All you have to do was do multiplication and subtraction. On to number 5. This is a fun one. So we have a square with area 4 and a square of area 5. This is B, this is A, and which tells, okay, and which, because these are similar, you just do this across. And if you're wondering why, it's just similar triangles, this angle are the same. So, we know that. Actually, let's prove it. Let's prove why, if this is A, this is B. So we have to prove the triangles are congruent. What's one way we can do this? Wait, angle side angle. That's a way that works. So, angle side angle. ASA. We know this side. And we know this side. They're the same. So if we want to prove this triangle are the same, we just need to prove this angle and this angle match. So let's call this theta. And now we know this is a right angle, it's a square. And we know the sum of the angles in a triangle is 180 minus 180. So if we subtract 90 in theta, we know this angle is 90 minus theta. Okay? And now this is a straight line. So this entire thing is 180. So, but this is a square. This is 90. This is theta. So this angle must be 90 minus theta. And this is 90. And this must sum to 180. And we already have 180 minus theta. So this is theta. So we have angle, side, angle, angle, side, angle. So we know they're congruent. Which means we can label this entire thing like this. And we want to find A times B. Wait a minute. A times 1/2 A times B equals the area of one of the triangles. Let's think about it again. The area of the area of 4 triangles is equal to 5 minus 4. Because this area is 5, this is 4, so this blank space, like all this, must be 1. So what do we have? 1/2 AB times 4 equals 4 triangles, which equals 1. So we have 2AB equals 1, so AB equals 1/2. So for this one, we just had to realize that all these triangles are the exact same. And because we want to find AB, we can multiply these, and 1/2 AB equals the area of one of the small triangles, but we have 4 of them, and the total area is 1. So the area of each small triangle is 1/4. So AB must be 1/2. So 1/2 times 1/2 equals 1/4. Any questions on the set? If there aren't any questions, you can take a short break. But you have, if you don't want to take the break, you can start classwork 2 right now. But you have until 9:20 to finish week 3 classwork 2. And if you have any questions on any of these 5 questions, just message me and I'll answer. Okay, it's 6:20, so let's just start with these. Oh yeah, how long do you have the questions? It's up. Yeah, there's not much time left. Just 10 minutes. I'm gonna run through these questions real quick. You can keep working. Question 5 is sort of fun. Well, let's start with one. Peter's family ordered a 12-slice piece of pizza. He ate one slice and shared another slice equally with his brother. So he ate one plus equally shared one half and over the total amount of pizza. This is the final fraction he ate. 3 halves over 12, which equals 1/8. Okay, on to number 2. Two-legged bird and a number of four-legged mammals. So 200 heads. So let's write a system of equations. Each bird has one head, hopefully, and each mammal also hopefully has only one head. So 200 total heads. And each bird has 2 legs, and each mammal has 4 legs. Okay, so let's multiply this by 2. Normal system of equations. Subtract them. Okay, how many? 61. And now we want to find birds. We get x plus 61 equals 200. There. This is something everyone who sent to me got, so I'm gonna go through this one quickly. So you get more, spend a bit more time in the back. If I went too fast on this one, just tell me. But system of equations, something you should all know. Yes. 3. In Big N, the number of middle school football conferences, each team plays each other team exactly once. Their total of 21 conference games. Okay, let's do this. If there's 2 members, let's find a pattern. There's 2 members. They get to play each other once. Okay, there's one. There's 3 members. How many total games? A can play B, B can play C, A can play C. There's 3 total games. But the 4 people, there's 6 total games. Wait, let's find one more to confirm our pattern. With 5 people, a total of 10 games can occur. You can see every time we add 1 here, we're adding 2 plus 3 plus 4. And would you know it? The correct answer is actually plus 5 for this one. So 7 total teams. There's 21 games. But it doesn't stop there. Say we have n teams. The number of games is actually equal to n times n minus 1 over 2. And we can see this is true. 2 times 1 over 2 is 1. 3 times 2 over 2 is 3. 4 times 3 over 2 is 6. 5 times 4 over 2 is 10. 6 times 5 over 2 is 15. And 7 times 6 over 2 is 21. No, 17s. Number 4. So, in a jar of red, green, and blue marbles, all but 6 are red marbles. So what does this tell us? All the marbles, except for 6, are red. There are 6 red. All but 8 are green. Wait, I might have read that wrong. So all the marbles except for 6 are red. Okay. All the marbles except for 8 are green. And I don't think I read that right. So all the marbles except for 6 are red marbles. And all of the marbles except for 8 are green marbles. And finally, all the marbles except for 4 marbles or blue? Okay, so let's think about it. We know all but 6. So what does this tell us? G plus B equals 6. What does this one tell us? Well, we know everything here isn't green, so red plus blue equals 8. And we know everything here isn't blue, so red plus green equals 4. Now let's add these. And would you look at that? Red plus blue plus green is equal to 9. Any questions? If there aren't any questions, let's move on. 5. A circle of radius 2 is cut into 4 congruent arcs. The 4 arcs are joined to form the circle figure shown. What is the ratio of the area of the star figure to the area of the original circle? So, think about it. Let's actually draw a square. Let's draw a quarter of a circle. Another quarter. Another quarter. Another quarter. Wait. This is actually what the shape is. It's 4 quarter arcs joined together. And what do we know? The radius of each is 2, right? So, and how do we find the area of the shaded spot? We find the area of the whole thing minus the white area. What is that? 4 times 4 equals 16. Now we subtract the area of the circles. Each is a quarter circle. So you do minus 1/4, and there's 4 of them. So times 4 radius, pi r squared. What do we get? 16 minus, these cancel, 4 pi. Now, what is the area of the whole circle? Well, this is very simple. It's a circle. So you get pi r squared equals 4 pi. What is the ratio of the star figure to the area of the original? Well, star figure to original. And then we divide everything by 4. And this is our answer. Any questions? Sorry for going a bit fast in the end, but I felt bad for keeping you guys long every time, so I wanted to finish on time this time. If you have any questions, you can stay and ask me. Otherwise, you guys are good to go for today. See you guys.